Hello, we are discussing about GATE 2004 ECE paper. The number of memory cycles required to execute following 8085 instructions LDA LXI. The right answer for this question is B. B is the right answer for this question. And you must understand one thing, here memory cycles is asked. What it is asking is memory cycles. Memory cycles is equal to machine cycle. But machine cycle is not always equal to memory cycles. Remember that one. Memory cycles are nothing but machine cycles, but every machine cycle is not a memory cycle, because machine cycle is going to be defined as the time required to complete one operation by the microprocessor. The time required to complete one operation by the microprocessor is generally treated as machine cycle. That one operation can be either accessing the memory, that means memory read or memory write, or accessing I by O, that means either it may be IO read or IO write, or it may be acknowledging an external request, interrupt request, hold request, okay, like this. So microprocessor is going to perform one complete operation in one machine cycle. So here in the question, memory cycles means nothing but machine cycles only. Okay. So if you observe the given two instructions, both are going to be of 3-byte instructions. Okay. B means number of bytes required to execute this instruction. So LDA is a 3-byte instruction and LXI is also 3-byte instruction, and number of machine cycles required is, for LDA it requires 4 and for LXI it requires 3. Number of T states required is 13 for LDA and 10 for LXI. We will see why it requires, LDA requires more machine cycles than LXI. LDA instruction can be written like this. LDA 16-bit address, 16-bit address, whereas LXI can be written as LXI D, 16-bit data. Okay, remember this one. LDA 16-bit address, load accumulator with the data present at the 16-bit address mentioned in the instruction. That is what the above operation. LDA operation is nothing but it loads the accumulator with the data present at 16-bit address which is mentioned in the instruction. Whereas LXI D, 16-bit address, 16-bit data, that it is going to load register pair DE with the 16-bit data shown. Okay, because LXI itself is going to be treated as LXI RP, you can write LXI RP, register pair. LXI register pair, 16-bit data. It loads the register pair with the 16-bit data mentioned in the instruction itself. But it has register pair can be either D or B. D means DE register pair, B means BC register pair, or it can be HL. Okay, HL register pair, H. Otherwise, it may be a stack pointer also. So microprocessor knows by knowing with opcode fetch for D. For D, it is 11 opcode fetch. Opcode required for this one. For B, it is 01. For H it is 21 and for SP it is 31. So by looking at the opcode, that is while fetching the opcode, microprocessor knows that one which register pair it has to load with the 16-bit data mentioned in the instruction. So it directly knows that one. It is going to, by looking at this instruction, okay, by looking at this instruction, LDA is going to be mentioned like this. First 3A is the opcode for LDA 16-bit address, and that address is going to be shown with lower 8 bits first, that is 00 and 30. So it will be specified in this way. While loading the program, 3A, 00 and 30. These 3 bytes are going to be stored in the memory such that first it will fetch a 3A and it understands that one it has to load the accumulator with the 16-bit with the 8-bit data presented 16-bit address given in the next 2 bytes. So this is lower 8-bit address and this is higher order 8-bit address. So accumulator is going to load from data from 3000 location. So first it requires fetch operation to know what it has to do, and second one is memory read operation to get the lower 8-bit address, and next one more memory read operation it requires to get the higher order memory address. So after 2 read operations it knows the entire address, that is 3000. From that one it has to get the data. Again it requires one more read operation to get the data from that location. So this LDA requires 4 operations. One is opcode fetch and the other 3 are going to be memory read cycles. If you come for the LXI is going to be mentioned in this way. LXI D comma 16-bit data whose opcode is 11, and F1 next lower 8-bit data, F0 is upper 8-bit data. 11 F1 F0 is going to be the sequence entered while executing this instruction. So first microprocessor reads this 11, that means opcode fetch understands that one. 11 is specifically for the DE register pair. So microprocessor understands it has to load register pair DE with the 16-bit data present in the address, and it knows that on first the data whatever it comes it is lower 8-bit data. So as soon as it gets the data in the second machine cycle it will be copying that into the L register, and the third machine cycle it is going to get the upper 8-bit data. As soon as it gets the upper 8-bit data, okay, in the third T state of that machine cycle it will be loading it into the D register, because it know before itself, that is after going through the opcode fetch it knows everything. It has to load DE register pair with the data present in the instruction itself. As soon as it gets the data it will be loading into those registers. So it requires only a fetch operation and one memory read operation, second memory read operation. So it requires only 3 machine cycles, whereas LDA requires 4 machine cycles. Thank you.